Okay, this lesson is on simplifying radicals. So before we start simplifying radicals, we need to talk about perfect square numbers. Perfect square numbers are numbers that have a square root that's a whole number. So a perfect square number would be 1 because the square root of 1 is 1. Another perfect square number is 4 because it has the square root of 2. We could continue on and say our next perfect square is 9. The square root of 9 is 3. 16 is our next one. The square root of 16 is 4. And then we have 25. The square root of 25 is 5. We know the square root of 36 is 6. Up next is 49. That square root is 7. And then 64, whose square root is 8. 81, which has a square root of 9. And 100, which has a square root of 10. So when we're trying to simplify a radical, we want to be looking for these numbers underneath this radical. Okay. So let's look at an example problem to see what I mean by that. Okay. So here we have the square root of 63. The first thing we want to do is we want to look for one of those perfect square numbers, or a number that has a square root that's a whole value. So 63, okay, we can say 63 is 1 in 63. Okay. 2 does not go into 63. I can say 3 and 21. These are factors of 63. 4 does not go into 63. 5 does not go into 63. Neither does 6, but 7 does, and it's 7 times 9. These are all the factors, or the numbers that multiply to equal 63. We want to find the set of factors with the biggest perfect square. So in this list, I can see I have a perfect square of 1 and a perfect square of 9. 9 is the biggest perfect square, so that's the one we're going to use. So instead of writing the square root of 63, we're going to write the square root of 9 times 7. Okay. And with radicals, when you have multiplication, you can split those into two separate radicals. Square root 9 times the square root of 7. And this is why we want the perfect square number, is so one of these will reduce down to a whole number. The square root of 9 we know is 3, so 3 square root 7. Before we say we're done, we want to check the radical to make sure that it's the simplest form, or in other words, that we can't reduce that. 7 is actually a prime number, so we're good. There's no perfect square numbers that will go into 7, so that would be our final answer. What about 112? Well, what you want to start off with is finding the biggest perfect square that goes into 112. Instead of listing out all the factors of 112, let's focus on just finding the perfect squares. So our first perfect square is 1. Well, 1 goes into 112. Okay. The next perfect square is 4. 4 does go into 112. 4 times 28 is 112. Our next perfect square is 9. 9 does not go into 112. 16 is the next one. 16 does go into 112. It goes in 7 times. After 16 is 25, and this does not go into 112. 36 does not go into 112. And then we have 49. 49 is not a factor of 112. And 64. Okay. Also does not. 81 is not a factor either. So when we list out our perfect squares and look for the factors of it, we can see 16 times 7 are the factors we're going to use. 16 was the biggest perfect square that went into 112. So I can rewrite this as 16 times 7 all underneath my radical. I'm going to split this into two separate ones. So square root of 16, square root of 7. And we know the square root of 16 is 4, so it becomes 4 square root 7. I'm going to check and make sure my radical is simplified completely. 7 cannot be reduced in the radical, so we're all set. But what if I have something like this? Square root 15 times the square root of 12. Well, just like we were doing with splitting the radicals apart, when we multiply, we can put them together. Square root of 15 times 12. So 15 times 12, that becomes the square root of 180. So now all we're doing is simplifying the radical with the square root of 180. So I'm going to write out our perfect square numbers. I'm going to give you guys a moment. I want you to hit pause. I want you to find the biggest perfect square that goes into 180. Okay, don't forget, hit pause. I want you to try this first. Okay, welcome back. You should have found that the biggest perfect square factors of 180 was 36 and 5. So I have the square root of 36 times 5 all underneath my radical, but I'm going to split that up. Square root of 36 times the square root of 5, and I know the square root of 36 is 6, and then I have the square root of 5. And I double check underneath my radical is all good. 5 cannot be simplified, so we're done. This one's a little bit different. Notice there's a coefficient. That 3 is out in front. We're going to ignore that 3 for now and focus just on the square root of 98. Okay. So again, I'm going to go through all of my perfect square numbers. I'm going to find the biggest perfect square that goes into it. So 1 in 98, 4 does not, 9 does not, 16, 25, 36 all do not, but 49 does twice. Okay. And that's going to be my biggest perfect square. So again, ignoring that 3 out in front, we're going to focus just on the 98. 49 times 2. So the square root of 49 times the square root of 2. We know the square root of 49 is 7, and then I have that square root of 2. But we're not done at this point. Remember, we still have this 3 out in front. So now that we simplified the radical, we're going to bring that 3 down. And he's out in front, and he's a multiplication. So now we're going to multiply those outsides. 3 times 7, 21, and then I still have my square root of 2. Now we can double check that we've accounted for everything. At the original problem, I had my coefficient. Yes, I brought him down and dealt with him and included him. And then my radical at the end is square root of 2, and that cannot be simplified. So 3 square root of 98 would simplify to 21 square root of 2. Why don't you guys go ahead, hit pause again, and try simplifying this radical expression on your own. Okay, welcome back. Hopefully you guys found a little bit more success as you keep going through these. So again, we're going to ignore that 4 and focus just on the square root of 75 to begin with. And you can see I've already written my perfect square numbers over on the left. I can see that 75, the biggest perfect square that goes into it, is 25, and it's 25 times 3. I'm going to break those apart. So the square root of 25 times the square root of 3. And we know the square root of 25 is 5. So this becomes 5 square root of 3. But don't forget about your 4. So we're going to bring this 4 down. We're going to write them out in front as a multiplication. And the final step is multiplying those outside numbers. 20 square root 3 would be our final answer. Okay, one last problem. Okay. We're going to look at this, okay, the square root of 108, and I want to use this as a point to talk about what if I don't find the largest perfect square when I begin. Okay. If I'm looking at this, okay, I see a square root of 108, and I go, oh my gosh, I know 4 goes into that. Okay. I'm going to rewrite this as the square root of 4 times 27, because 4 times 27 would be 108. I split it apart, the square root of 4, square root of 27. And we know that the square root of 4 is 2, and then I have this square root of 27. When I go to check to see if I'm done, I'm going to notice that 27 has a perfect square that goes into that. 27, the perfect square that goes into it is 9. So now we're going to look at this as just its own separate problem, 2 square root 27. So we're going to ignore the 2 and focus on the 27. Square root of 9 times 3 is 27. So we break this apart, the square root of 9, the square root of 3. Square root of 9 is 3, and then I still have a square root of 3. And come back up and grab that coefficient, 2 times 3, square root 3. Multiply the outsides. 6 square root 3 would be our final answer. So if you're not finding the largest perfect square, it's okay as long as you're going through and checking, is there another perfect square that goes into it? You will save work by finding the largest perfect square number, but if you don't or you're not sure, you do have a way to check and continue working through the problem. So that's the end of our examples for today. Let's just point out a few things to remember. We're always looking for the largest perfect square number. 1, 4, 9, 16, 25, 36, 49, 64, 81, or 100. Make sure you find the largest one. Check all of them. And when you end up with two radicals next to each other, you want to multiply those inside. So there's the example, square root 2 times square root 5. You're just going to multiply the stuff inside together, the square root of 10. And do the same thing for the outsides. Multiply the outside stuff together. 3 times 4, square root of 7. Multiply those outsides. 3 times 4 is 12. So 12 square root 7. And that's all for our simplifying radicals lesson.